3, 2, 1. The title of this presentation by myself, Charles Sven, is Chaos to Creation, a 25-year study that includes the initial Big Bang event, dark energy, galaxy formation, and space acceleration, amongst other things. The website is allnewuniverse.com. Greetings. My name is Charles Sven. I'm an observational and theoretical scientist immersing myself into an independent study of cosmology and creation since 1997. I've presented my evolving work at 22 conferences. They're listed at my website, allnewuniverse.com/public talks. Much of this presentation has been derived from my latest book, available at Amazon, The Big Bang Book, How, Where, and When Demonstrated, including that galaxy formation and the physics of powerful dark energy. It includes over 400 quoted references. Amazingly, that initial Big Bang event was created with old 3D physics so common that this 3D physics was overlooked by all up to now, and is being presented here in a step-by-step format for ease of understanding and recognition. As an introduction, to get us on its way, I'm going to start with a lighthearted story about that very powerful dark energy, the source of the initial Big Bang event's power. Two atoms walk into a bar and order shots of old dark energy. That lovely carbon atom from the wooden match colony meets her friend uranium-235 from the Rock House band and orders a double shot of dark energy. After which she starts telling us that when she is tanked up on dark energy, she, with her speedy electron arms, can fling out light photons out at 186,000 miles per second. Wow! That's great, says this husky uranium-235. You know that when me and a few of my band member friends get tanked up on dark energy, we start a jam session that can end with an atomic blast that can be seen for miles around, all in a flash. How about that for a very powerful jam session? Up to now, no one questioned where these atom electrons' power comes from, and no theory exists explaining the source. So, on that note, let's leave our friendly atoms to their banter, and let's try to learn all that we can about the physics of dark energy. Here is one of the latest formal statements about dark energy from the Dark Energy Survey reported May 27, 2021 by Formulab, which stated that dark energy, which cosmologists hypothesize, drives the accelerating expansion of the universe that increases the space between galaxies by counteracting the force of gravity and accounts for about 70% of the total mass energy of the universe. Hypothesize is another word for assumption. All of this work presented here is all based on 3D physics observed, in which I will present overlooked physics about dark energy. This is that dark energy survey camera found on top of the Blanco 4-meter telescope in Chile, installed in 2012. Also, very new here is the new James Webb telescope that detected the most distant galaxies ever observed this past July 2022, with some galaxy redshifts apparently approximately Z = 20. These very young galaxies found right next to the cosmic microwave background radiation field called the CMB. These very young galaxies are virtually embedded in this CMB. What we know: the space in our universe is filled with galaxies in every direction, from that Andromeda galaxy next door all the way out to some farthest galaxies seen some 13 billion light years away distance, as shown in this daisy picture graph. And now We see even further with the James Webb Deep Field that spotted those very young, approximately Z20 galaxies found next to the C and B, or that cosmic microwave background radiation field, almost virtually embedded in the C and B. Those Z20 galaxies were reported by the CHEERS group. Currently, we note that the distances between Earth and the Milky Way galaxy and most galaxies is increasing. So based upon the increasing distances between galaxies, many are of the opinion that space is expanding and accelerating. By retracing that growth, we note that the universe shrinks all the way down past the so-called singleton point to nothing. The properties of a singleton have to be like the smallest black hole ever, but one that contains all the atoms in the universe arising out of nothing and is so dense that it does not have any internal mechanisms allowing it to explode. A fantastic hypothesis, unacceptable to many. What we don't know: how did all the matter that formed galaxies materialize out of nothing? The current cosmology believes in the assumption that all matter sprang out of nothing as a very tiny singleton and somehow magically exploded. There are no physics supporting this assumption of a singleton. What we need is to find the physics that explains how we come from no space, empty space, or nothing. To help us start, we need to eliminate that assumed singleton and that assumed beginning from nothing. The biggest problem in cosmology is that unknown. What were the initial conditions of the Big Bang, creating that initial event? Without a big beginning, everything that follows is an assumption, hoping that these assumptions will hold up when we discover what the initial conditions were. Every skyscraper must have a strong foundation in order to survive, but the assumptions of cosmology, like the building of a skyscraper, has no such foundation. All these mathematical concepts about the Big Bang assume they will work after we find that initial condition. But current cosmology is similar to constructing a skyscraper without a foundation. It starts from nothing. It has space expanding from nothing. Counterintuitively, somehow this expansion began to inflate beyond any physics observed. This singleton comes into the picture without any large atoms like oxygen, carbon, or uranium capable of exploding. Mathematically, the singleton is described as being homogenetic with no center, and we've topped all this with a possible super fast forming set of galaxies. Try to build a skyscraper without a foundation. It's not realistic. And so there goes our cosmology assumptions. So how to progress? We should use Richard Feynman's technique, the best way to learn anything. Start from scratch. Richard Feynman needed to fully understand every problem he encountered by starting from scratch, solving it in his own way and often in several different ways. So writes Lawrence Krauss in his book Quantum Man, Richard Feynman's Life in Science. So, how to find the physics needed? We need to study something as tiny as a singleton, like atoms. That's the key to finding dark energy. Study atoms, and that's what I did. In that light, what follows are a number of replicable observations. When properly arranged with deep thinking, allows us to understand atoms and how the physics of chaotic dark energy was employed in the creation of our universe, before, during, and after the initial Big Bang event. The most important thing that we need to keep in mind for this analysis is what the greatest of physicists, Richard Feynman, told us. All things are made of atoms. The current estimate of all the atoms that make up our universe is about 10 to the 80th power, and were all created in the Big Bang era, computed by NASA now to have occurred back at least 13.8 billion years ago. Scientists wanted to know, how long do protons in atoms survive? They created several studies, and this latest U.S.-Japan cooperation created this super kamikaze 50,000-ton tank of ultra-pure water lined with sensors running since 1996. As of today, no atoms or protons self-destruct, which meant that the minimum life of an atom far, far, far exceeds the current estimated life of our universe. And we have some new technology to help us find out how dark energy works. The non-contact atomic force microscope, invented in 1987. When viewed under this latest non-contact atomic force microscope, the atoms look remarkably like spherical ball bearings. But remember, there is no eggshell around the atom. What we see are those electrons rapidly orbiting the nucleus, covering every surface in a spirographic pattern. And following up on that, the latest picture is tracking spherical atoms in a liquid via the transmission electron microscope, reported July 2022. Spherical atoms. Here's where we start to observe overlooked common 3D physics up to now. Using that information up to now, we start by assembling some of these ancient spherical atoms into a match. When struck, emit light photons instantaneously at 186,000 miles per second, indicating that some power is driving those electrons at light speed. And at that speed, they are making approximately 1,000 trillion orbits per second, giving us that ball-bearing shape. This is the mystery of what's happening in the quantum world. Dark energy, or something, must drive those electrons. Dividing the distance that light travels in 1 second by the circumference of an atom equals approximately 1,000 trillion orbits per second, creating that spherical shape. This dark energy is what Einstein searched for in a search to find the nature of the quantum world that he never found. Up till today, science has no theories on what drives electrons. Dark energy is the only physical power on the horizon to do that. And we must note that that so-called kinetic energy of motion is associated with atoms being driven by the only existing theory, that of mine presented here today, dark energy. Dark energy, described with 3D physics. What we know about light photons. From a match, we see the light, painless. But put your finger near the flame, and we get burned. Add more light photons from a dynamite explosion, and we can blast a hole in rock. Add even more light photons coming from an atomic bomb, and we can destroy a city. Finally, squeeze atoms in a star's huge gravity field, and starlight photons supports life on Earth. About dark energy, orbiting electrons, and light photons moving at the speed of light. That dark energy has to be very powerful. To get an idea of how powerful dark energy is, we note that less than 1 tiny gram's worth of ancient uranium atoms was consumed by the first atomic bomb that destroyed a city. So when uranium atoms are properly configured for fission, these huge uranium atoms split into 2 smaller atoms, releasing 3 neutrons, and as a byproduct, releases powerful light photons during a chain reaction and is powerfully destructive. Powerful dark energy drives the electrons in every atom, and powerful light photons are ejected during atomic bomb fission, as well as from stars due to the star's huge gravity fusing atoms, expelling excess powerful light photons driven by dark energy, seen as starlight. In these merging galaxies, as well as in all galaxies, tremendous power is constantly required to keep stars shining for billions of years, driving those spherical star atom electrons. And it has to come from someplace. The best choice is dark energy. How many stars are powered by dark energy? In the latest NASA estimate, our universe holds over 200 billion galaxies, averaging over 100,000 stars each, all with starlight photons pushed by electrons driven by dark energy. No 13.8 billion volt battery pack does that. No tiny atom-sized battery works that long or can hold that much power. Continuing our observational-based deep thinking study, this chaotic dark energy must fill all of space and must move at very high velocities, evidenced by pushing electrons in atoms that drive starlight photons at light speed, and very powerfully provides the needs of all the atoms in these billions of star-filled galaxies. Noting that such powerful chaotic dark energy driving those electrons at light speed must move like roaring rivers at the speed of light around the universe and must incur normal high-speed pulsating instabilities as seen in some of the most powerful pulsating graphs of supernova and gamma ray burst explosions as recorded by NASA. In this 2008 highly pulsating supernova chart, the black lines record those very energetic light photons called X-rays from this pulsating explosion. The red line is just the statistical average of these very energetic light photons, and like in a match presented earlier, are driven by electrons powered by dark energy. This supernova flashed 100 billion times brighter than the sun at that time. That's why we see them buried in galaxies. They are so bright. But they're small compared to the thousands of pulsating gamma ray bursts called GRBs, which shine hundreds of times brighter than supernovas and are around 1,000,000 trillion times as bright as the sun. Pulsating GRBs are the most energetic light photons that we can sense with all our modern technology. NASA records at least one gamma ray burst a day. So, how do we go from chaos to creation and that initial Big Bang event? We need to continue with our pulsating instability studies such as turbulence, flutter, and buffeting, as seen in earthworks, that suggest that over eons of time, this chaotic dark energy must have traveled over every possible pattern until a sufficient amount of this very powerful chaotic dark energy pulsatingly converged into the small enough space, probably forming trillions of laser-like beams before setting off the combining conversion of the chaotic dark energy's virtual particles into atoms, just as they did at Stanford Labs, where a tiny amount of atomic matter was created by smashing massive energy beams in '97. How to create atoms? In that both electron and proton beams are relatively easy to make in the lab, but atoms are much more difficult to make, as seen at Stanford, which shows that staggering amounts of energy are required to create even the tiniest particles of matter. Consequently, I presume that while turbulent chaotic dark energy is converging, but not until it reaches maximum convergence and density, does chaotic dark energy combine virtual particles into atoms. The atoms bubbling out and trapping space at the unbelievable increased volume, 248 trillion times the volume of its proton, all in a flash. The volume of a hydrogen atom divided by the volume of its proton equals that ratio, 248 trillion to 1. So, in the twinkling of a cosmic moment, the estimated 10 to the 80th power number of atoms filling our universe, growing like a balloon, pulsatingly bubble out some 248 trillion times the volume of protons to manifest as the Big Bang in a very highly pulsating, turbulent, buffeting process, bubbling shell after shell of ballooning atoms so furiously that the first shell crop of ballooning atoms created is driven by the second shell, which is driven by the next shell of ballooning bubbles, so forth, resulting in the first shell moving away from the epicenter at near the speed of light, and each succeeding bubbling shell is pulsatingly driven with less push and slower speeds until the density becomes too thin to continue the process, all in that creative cosmic moment we now call the initial event. Further, that first shell of ballooning atoms, pulsatingly bubbling away from this initial Big Bang event, reaches its midpoint of travel out into space, radiating its diminishing power in all directions. And once that radiation passes by, it's replaced with radiation from its new farther out position, always moving to the midpoint. How light works, and what is that midpoint? That's like watching a departing car's taillight that's driving away from a viewer. The light comes from further and further away, is dimmer and dimmer, and takes longer and longer to reach the viewer. We only see the light from the location where the departing car's taillight was emitted, not its actual farther out position. So, when that first shell of ballooning atoms reached a position some 13.8 billion light years out from the initial event, radiation from that midpoint location, as measured by NASA, took a second 13.8 billion years to shine back to the epicenter, where the last atoms created bubbled out at 0.2% or less than that of the speed of light. NASA's data supports our very slow-moving galaxies, which is found next to the epicenter of our universe. That 0.2% is based upon the NASA 89 to 93 COBE satellite study that computes Earth's velocity to be 600 kilometers per second, equaling 0.2% of light speed, or 372 miles per second. We, in the Milky Way galaxy, are one of the slowest moving galaxies, with almost everyone else moving away from us. We are moving comparatively so slow to these star-filled galaxies that we could say we are virtually in the center of our universe. We are just 0.2% of the radius out to the CMB. However, not all galaxies are moving away from Earth. The Milky Way galaxy and Earth, there are about 100 galaxies moving towards us. That's not easily explained by that supposedly very powerful expanding space force driving galaxies apart. Further observations of merging galaxies made by NASA generated a broad range of results. Anywhere from 5 to 25% of the galaxies were merging. That assumed powerful space expansion driving most galaxies away from Earth must have an awful lot of holes in it for mergers to occur. This is the first undistorted picture of the cosmic microwave background radiation, usually called the CMB, radiation from the midpoint of atoms' travel, a sphere derived from the NASA dominant MAP satellite data processed by Dr. Max Tegmark, who at that time in 2003 was at the University of Pennsylvania. This was published by the BBC News, in which Dr. Max Tegmark notes that the entire observable universe is inside this sphere with us at the center of it. Here we find us Earthlings in the center of this huge CMB sphere surrounding us, coming to us from 13.8 billion light years in every direction. Let's look at the bubbling out in more detail. That first shell of atoms bubbling out is driven by the next shell bubbling out and pushes that first shell out to near the speed of light, out into gravity-free space, and now is as dense as a fog, and is now at the midpoint of its outward rush into space, and it's that midpoint edge that reflects galaxy light from the James Webb Space Telescope's slower-moving, approximately Z20 galaxies, but is not dense enough to form galaxies on its own. This first bubbling shell is driven by the next shell, and by the next shell, and so forth. So what we see today is the CMB coming to us Earthlings from all directions, 13.8 billion light years equally, placing Earth in our very slow Milky Way galaxy right next to the center of our universe. How long did it take for the CMB radiation source to grow to that midpoint position, now shining back to Earth? 13.8 billion years. 13.8 billion years atoms out from the initial event epicenter, and 13.8 billion years radiation return from the CMB field, the midpoint of its travels. That equals 27.6 billion years elapsed since the initial events. This is the age of all atoms. This is the age of our universe, 27.6 billion years. In the meantime, those first bubbling atoms are continually traveling out into space unabated as far as we know. Just like all galaxies are moving out from the bubbling explosion of atoms. So this is what we see. Just the light from the midpoint of all celestial objects, including the cosmic microwave background radiation. Earth, as part of our Milky Way galaxy, like all atoms age of 27 billion years times its relatively very slow speed of 372 miles per second, that NASA Kobe speed, equals roughly a scant approximately 55 million light years traveled out from the initial Big Bang event's epicenter, just 0.2% of the distance out to the CMB. Our super slow traveling Earth, as part of our Milky Way galaxy, is virtually right next to the initial event's epicenter of our universe. Our component atoms being about the last out of the bubbling conversion of virtual particles into bubbling atoms. That puts our centrally located Earth surrounded by billions of galaxies, all lit up by dark energy. Further, we have some very strong evidence supporting Earth in our Milky Way galaxy's central location, and from some space and Earthbound telescope views that supports this concept that our very slow-moving Earth is next to the center of our 27.6 billion-year-old universe. They are luminous red galaxies, quasars, the north and south deep field galaxies, the surrounding cosmic microwave background radiation, and DAISY, the latest and most inclusive 3D map of galaxies. This first picture graph with very slow Earth as part of the Milky Way galaxy at the bottom of the screen is really in the center of luminous red galaxies. Here seen both above and below the stars in our Milky Way galaxy that prevent a complete view and are distributed like onion layers around our Earth in opposing pie-sliced views. Luminous red galaxies distributed around Earth and the Milky Way galaxy in onion-like layers are not homogeneous. The assumption of homogeneity implies that there's no preferred position, and very slow Earth in the Milky Way galaxy is not near the center, contrary to our views of these luminous red galaxies surrounding us. This distribution clearly shows the demarcation of luminous red galaxies surrounding Earth and is not an optical illusion. This Sloan Digital Sky Survey of luminous red galaxies clearly positions Earth as part of the Milky Way galaxy in the center of these red galaxies. And they were photographed by the very sophisticated Sloan Digital Sky Survey telescope at Apache Point, New Mexico, eliminating optical illusions. This second picture graph comes from Australia, called the 2DF Quasar Redshift Survey, showing Earth, very slow Earth, again as part of the Milky Way galaxy, in the center of quasars, uniformly distributed again like onion layers on opposite directions, above and below the stars in our Milky Way galaxy. Here we find Earth and the Milky Way galaxy in the center of quasars, distributed in onion-like layers, which cannot be considered homogeneous. This 2DF quasar pie chart was viewed using the Anglo-Australian telescope. Important to the telescope's success has been a state-of-the-art instrumentations which are constantly being upgraded and improved, eliminating that assumed concept of optical illusion. This quasar chart covers our whole visible universe going out 14 billion light years in each direction, with Earth surrounded by quasars in onion-like layers, denying homogeneity. Quasars emit staggering amounts of electron-driven light photon radiation across the entire electromagnetic spectrum. This third picture graph finds very slow Earth as part of the Milky Way galaxy in the center of the Hubble Space Telescope's North and South Deep Field Galaxy surveys. And when placed on a celestial map, like the one shown above on the right, we find that Earth is in the center of these NASA-viewed opposing deep field galaxies, each field over 13 billion light years distant from Earth in opposite directions. This midpoint location chart is from my latest, The Big Bang Book, How, Where, and When Demonstrated, page 45. Very slow Earth as part of the Milky Way galaxy in the center of these North and South Deep Field Galactic surveys is too small a sample needed to determine homogeneity. But by triangulating these two galaxy fields, along with the cold spot, places Earth right next to the center of our universe, a very prominent position. That cold spot was found embedded in the cosmic microwave background radiation field. This galaxy survey was recorded using this Hubble Space Telescope by the director, who's not expecting to see anything so far away, but he had some discretionary viewing time and searched out to the edge of the telescope's capacity and found these very far distant galaxies, to the amazement of all. This fourth 3D picture graph, which we've seen already several times, finds very slow Earth embedded in the Milky Way galaxy is virtually surrounded in the dead center of the surrounding CMB sphere. Every direction of the CMB sphere viewed from Earth is unique. Each of those spots are unique. That midpoint of atoms traveling out into pre-existing space is not homogeneous, and the outrushing light from every CMB atoms is moving out into space. This 13.8 billion light year distance of the CMB is recorded by COBE, WMAP, and Planck satellites. Here is that NASA WMAP satellite, a highly sophisticated instrument that also eliminates any possibility of assumed optical illusion. This is that DAISY picture graph taken by the Dark Energy Spectroscopic Instrument, which up to now has mapped more galaxies than all previous 3D surveys combined. Earth in the Milky Way galaxy is actually in the center of these 400,000 galaxies. This distribution is definitely not homogeneous. This graphic is a slice through the 3D map of 400,000 galaxies taken from the first few months of the Dark Energy's spectrographic instrument. Very slow Earth is at the center, with the furthest galaxies plotted at distances of up to 10 billion light years from Earth. Each point represents one galaxy. This was posted by the Science Tech Daily, January 24th, 2022. DAISY was mounted on a 4-meter Mayall telescope at Kedping National Observatory, located 56 miles southwest of Tucson, Arizona. All these telescope views kill that mathematically assumed Copernican or cosmological principle that claims that our very slow Earth and our Milky Way galaxy have no preferred position in the distribution of galaxies in our universe. Further, as we have shown, we have 5 very sophisticated telescope views of our universe, eliminating any assumptions of optical illusions or homogeneity. The Copernican principle is the cornerstone of most of astronomy. It is assumed, without question, and plays an important role in many statistical tests for the viability of cosmological models, said Albert Stebbins of Fermilab. Continuing, it is also a necessary consequence of the stronger assumption of the cosmological principle, namely that not only do we not live in any special part of the universe, but there are no special parts of the universe. Everything is the same everywhere, totally ignoring the telescope views I just presented. Realistically, this Copernican principle is misread as well as misapplied. Earth's position in our solar system is very well located, observed, and understood. The same with our solar system in respect to our Milky Way galaxy. As all these telescope graphs and pictures show, we certainly know where our Milky Way galaxy fits in our observable universe. This brings us to the next point of this presentation: galaxy formation described with 3D physics in a 27.6 billion-year-old universe. Bubbling atoms have plenty of time to allow gravitation, friction, and turbulence to form galaxies in every different size, shape, and direction of spin, all with 360 degrees of freedom, pushed by the original explosive bubbling driving force out into pre-existing space. With freedom of motion, galaxies can merge, or the gravity pull of clusters can cause small galaxies to move opposite of most. Our youngest Z20 galaxies, found right next to the cosmic microwave background, seen some 13 plus billion light years distance from Earth, took bubbling atoms around 14 plus billion years traveling to the midpoint location. And the light from those youngest galaxies from the midpoint took a second 13 plus billion years to reach Earth, a 27.6 billion year round trip. This is the age of all atoms. This is contrary to current cosmology. What NASA reported was that the youngest and most distant galaxy, 13.4 billion light years from Earth, named GNZ11 and now bypassed by some of the James Webb's later Z20 galaxies. Its immature regular shape, their immature regular shape, is typical for galaxies of that time period. That's all true, except saying that it was formed 400 million years after the initial Big Bang event. That was an assumption. NASA's reasoning was stated as, because the deeper you look in space, the further you see back in time. NASA concludes that galaxies several billions of light years away formed fairly soon after the Big Bang. Fairly soon is an assumption made without any deep thinking. That NASA assumed that the CMB was the light from the Big Bang. When anybody thinks about the CMB coming to Earth from every direction, as shown by Dr. Max Tegmark, is that radiation could only be a reflection from the inside of a sphere, not from a singleton source. Let's look at the CMB again, coming to very slow Earth from 13.8 billion light years in every direction, uniformly in every direction, not coming from a single source. The James Webb Space Telescope has detected the most distant galaxy ever known as CHIRS 93316. We're seeing it as it was just 235 million years after the CMB was formed. The reality of this galaxy, CHIRS 93316, located at the X mark on this graph, is that it is 13 plus billion light years from Earth, as reported by NASA. But it took some 14 plus billion years to reach this far distant location, not 400 million years. Cosmologists really do not know how long it took to form galaxies, nor the mechanics of formation. We'll discuss it later. This youngest galaxy must have been traveling at about 98% of light speed, a little slower than the first CMB atoms out, and took 14 plus billion years to go only some 13 plus billion light years distance, a 27.6 billion year round trip, the age of all atoms. Galaxy formation time, computed by Dr. Peter Lawson, recorded in his paper, How Are Galaxies Formed? He says, galaxies evolved not only by merging with other galaxies, but also through an internal process. This evolution is called secular. Secular means things that have no religious or spiritual basis, or magic. Secular processes take a few billion years. This presentation of mine is the only reasonable way that these far distant galaxies can be formed, and they have taken 14 plus billion years getting to that point. Some of the many challenges to galaxy formation reported are, for example, galaxy formation is a complex, nonlinear process driven by the interplay of many different physical mechanisms, so states Andrew Benson from Carnegie. Professor Volker Springerl says to produce realistic galaxies, modelers must drastically reduce the rate at which clouds of gas form stars from what astrophysicists expect. He says basically the molecular clouds form stars 100 times slower than you think. And Professor John S. Gallagher says we really don't know which is the dominant path yet to galaxy formation. And coming from Sven Butter, although the Milky Way is our home galaxy, we still do not understand how it formed and evolved. He's from the Australian National University. We find Cheers 93-316 galaxy located just 235 million years before the CMB in distance from Earth. Not a very young galaxy. In the meantime, the very slow moving atoms in our Milky Way galaxy took 27.6 billion years to travel just 55 million light years out of that bubbling explosion. During those 27.6 billion years, our very slow moving atoms use all the various forces of gravity, friction, and turbulence to form our magnificent giant spiral galaxy that we find ourselves living in right next to the center of our universe. Galaxies come in a great variety of shapes and sizes, like fingerprints, no two alike. In order to have such variety, each galaxy must have at least a 360-degree freedom of motion. That's only derived from a central bubbling push. Studying physics of dark energy from the beginning changes almost everything that we thought about our centrally located Earth and our 27.6 billion-year-old universe that comes from dark energy found in pre-existing space that lights up all those star-filled galaxies. Addendum, the last point today. Space expansion and acceleration. With Earth firmly in the center of our universe, I can talk about those mathematical assumptions of expanding and accelerating space. This space expansion and acceleration assumption was not required to explain the initial event of bubbling atoms out into pre-existing space, but the question of space is on some minds. Accelerating space expansion is a misreading of manipulated data called statistical average, along with a very old mathematical equation. That mathematical equation was presented prior to our view outside our Milky Way galaxy. Cosmologists needed something to explain why galaxies are moving apart from each other, so they latched onto William de Sitter's 1916-17 mathematical equation describing empty space expanding. The 1916 space expansion was composed prior to the construction of our telescope at Mount Wilson. Only later did Edward Hubble prove that our neighbor galaxy to be external to our Milky Way galaxy by measuring a variable star buried in that Andromeda galaxy. On mathematics, Richard Feynman says, the physicist had meaning to all the phrases, and there's a very important thing that a lot of people who study physics but don't come from mathematics don't appreciate, that physics is not mathematics and mathematics is not physics. One helps the other. What math does? Counts, measures, and compares. William de Sitter's equation in 1916 says that empty space expands. Well, there's nothing to count in empty space, and no points to measure. So, de Sitter's equation is nothing equaling empty space. That equation does not define space expansion. Not until someone quantifies an observation can math plus observation become physics. Any equation without observations is just a mathematical construction and can represent anything. So this is Wunderslitter's math equation. Start with nothing and end with nothing. Then empty, expanding space. 0 equals 0. Can 0 cubed be greater physically than 0? Pre-existing space, described as supernovas and gamma ray bursts. Adding to that expansion assumption, we add space acceleration based upon the Hubble Space Telescope's observation of supernovas. Note, the very far supernova scatter plot, seen with the Hubble Space Telescope, does not follow the one-to-one distance and brightness ratio seen in the relatively near supernovas seen earlier by Earth-bound telescopes. That statistical average rising curve, that dotted blue line, was the data that led cosmologists to believe that not only was space expanding, but that expansion was accelerating. Skip the statistically created upward curving average and examine just the scatter plot. Statistical averages can easily overlook valuable details and can get one into troubles. A bubbling explosion provides a better driving source for the shotgun-like distribution seen in the far right than that of a restricting, expanding, accelerating space mass assumption or construction. Here we have a shotgun pattern versus an expanding space pattern, both very different from each other. Let's compare the supernova graph with a very powerful pulsating gamma ray burst. Here's a very powerful pulsating gamma ray burst, trigger 1406. And so we see the circled section of the GRB curve on the left is like an opposing mirror image of the circled section of the supernova graph on the right, supporting an explosive bubbling push in space, resulting in a scatterplot distribution. This GRB trigger, 1406, could be a power model for the distribution of bubbling atoms shown out of the initial events, creation of atoms shown earlier. This GRB, like most, starts out very powerfully and rapidly declines, pushing out bubbling atoms at slower and slower speeds until the explosion ends, with slow Earth atoms bubbling out near the end. All this work presented describes that initial events and does away with all those Big Bang assumptions of time, space, and matter. Conclusion: there is no space expanding physics, nor do we have accelerating space physics. There is just the initial events in pre-existing space. So how to explain this cosmology? This great view of our universe, presented by the James Webb Space Telescope via galaxies found approximately Z20, helps cosmology to evolve up to the next level, embracing our evolving understanding of the physics of dark energy and space without the need of assumptions. We now have the foundation for cosmology, that initial events. Again, studying physics of dark energy from the beginning changes almost everything that we thought about our centrally located Earth and our 27.6 billion universe that comes from dark energy found in pre-existing space that lights up all those star-filled galaxies from their midpoint locations. I leave you with this final thought. Science finds the tools, philosophy seeks the craftsman. Much of this presentation has been derived from my latest book available at Amazon, The Big Bang Book, How, Where, and When Demonstrated, which has over 400 quoted references. If you felt that my presentation has merit, share this presentation or promote the study by getting a book from Amazon and giving it to a family member or friend or colleague as a conversation topic that you can both enjoy. Thank you all for your kind attention. This ends my presentation, and you may send me your questions by an email at info@allnewuniverse.com. And remember this picture of dark energy bubbling out atoms that form galaxies. And here are some of my allnewuniverse.com web addresses. 5, 4, 3, 2, 1.